Hello friends, welcome once again to my channel, Ojuk's Online Maths Class. In this video, I would like to teach you how to derive the basic trig ratios of special angles. I guess you all know what special angles are all about. We have special angles in the likes of angle 30 degrees, 45 degrees, 90 degrees, and the rest of them. So today, we'll be looking at how to derive the special angles or trig ratios of special angles of angles 60 degrees and 30 degrees. And to do that, we have to draw an equilateral triangle. So we have an equilateral triangle ABC, or if you are given an equilateral triangle ABC as we have on the board, this is an equilateral triangle ABC. So we all know that one of the major features of an equilateral triangle is that the three sides are all equal. So here, here, and here are all equal. So in this equilateral triangle, if here is 2 cm, automatically here is 2 cm. Here also should be 2 cm for an equilateral triangle. Now, apart from all the sides of an equilateral triangle being equal, another major features of an equilateral triangle is that the three angles are also equal. So if three angles of an equilateral triangle are equal, having recalled the totality of angle in a triangle, which is 180. If you are to divide 180 by 3, automatically we are having 60, which means that each of the angle of an equilateral triangle is equals to 60 degrees. So this is the second step. Now what do we do next? I will invent a perpendicular bisector to bisect this line CB at D. So if I invent a perpendicular bisector starting from A, I will have this to bisect line CB at D. I'm having this. So once this bisection is being done, automatically I'm now having to right angle triangle in this case. So this perpendicular bisector will not just only bisect this line CB at D. It will also divide this angle 60 degrees into two, which means this side will be 30 degrees. This side of the angle will also be 30 degrees. So I'm having two right-angled triangle with their respective angles and side. Now, if I'm to detach one of this right-angled triangle from this whole triangle, I'm having something of this nature. So I'll have this. This is B. This is A. This is 2 cm. Now, since from here to here is 2 cm, and I have bisected this line into two equal parts, it equally shows that from CD is 1 cm, and as well DB is also 1 cm. So now our line DB here should be D, our line DB here should be 1 cm, and our line D is unknown yet. Okay, we have 2 cm and 1 cm. Now their respective angles here, angle A should be 30 degrees from what we observe here, and our angle B should be 60 degrees. So we now have this. What do we do next? As you can see, this is a right-angled triangle. Now, observing this right-angled triangle, you can see two sides of this right-angled triangle are given, and one side here is missing. How do we get the remaining side of this right-angled triangle? Automatically, we recall Pythagoras' theorem. So if we want to get any missing side in a right-angled triangle, we recall the Pythagoras theorem. And what is Pythagoras theorem all about? So under Pythagoras theorem, we'll have it that line AB squared should be equals to line BD squared plus line AD squared. So if that is the case, line AB squared is 2 squared equals to line BD squared should be 1 squared plus line AD squared is unknown. What is that unknown? We want to know that is what we are solving for. Let's call it x. So it should be xa squared. So we are solving for x in question. So how do we go about solving for x? 2 raised to power 2 is 4 equals to 1 raised to power 2 is 1 plus x raised to power 2. Then we'll collect like terms. When we collect like terms here, we'll have 4, 1 crossing equality sign, we'll have minus 1 equals to x squared. So 4 minus 1 is automatically equals to 3 equals to x squared. Now to get the value of x, we have to find the square root of both sides of the equation. When we do that, we have that x is equals to square root of 3. So our x here should be square root of 3. So with this, we can get the three ratios of 30 degrees and 60 degrees with ease. Now, what do you mean by that? From here, we can then observe that cos, okay, let's start with sine. That sine 30 degrees is equals to, in trigonometry, sine is equals to opposite over hypotenuse. Now, what is the opposite of 30? Now, look at sine 30. I'll look at 30 here. The side facing angle 30 is the opposite of 30, right? Okay, what is the opposite of 30? We're having 1. So sine 30, which is opposite over hypotenuse, which is equals to 1 over, my hypotenuse is the longest side of this right angle triangle, which is 2. So I'm having 1 over 2. So sine 30 is 1 over 2. Then cos 30 is equals to, cos is equals to adjacent over hypotenuse. So what's my adjacent? This is my opposite, this is my hypotenuse. My adjacent will be root 3. So which is root 3 over 2. That is the value of my cos 30. Then I'll have tan 30. Tan in question is equals to opposite over adjacent. And the opposite of 30 here is 1 over, my adjacent is root 3, which is root 3. And root 3 is irrational, so we have to rationalize. When we rationalize, we'll have root 3 over 3. That is the value of tan 30. From here as well, we can get the values of three ratios of 60. So sine 60, if you are to observe this right angle triangle, sine 60, sine is equals to opposite over hypotenuse. So sine 60, what is the opposite of 60? Now we're going over to the angle 60 here. What is the opposite of 60? Opposite of 60 is root 3. So we have root 3 over, then hypotenuse is always 2, which is the longest side of a right angle triangle. Then cos 60 is equals to, what is cos? Cos is always our adjacent over hypotenuse. So what is the adjacent? This is 60, this is the opposite of 60, this is hypotenuse. Therefore, angle 60, the adjacent of angle 60 is 1. So have 1 over our hypotenuse is 2. So 1 over 2 is the value of cos 60. If you punch your calculator, it will give you the same value. Okay, then finally we'll have our tan 60. Tan 60 is opposite over adjacent. So what is the opposite of 60 is 3 over, what is the adjacent of 60 is 1. So we have that tan 60 is equal to 3 over 1, which is automatically equal to 3. So you can see deriving the three ratios of spatial angles is as easy as ABC once you know the tricks involved. Thank you for watching. Do not forget to subscribe to my YouTube channel at Ojuk's Online Maths Class so you can enjoy more of interesting topics like this in mathematics. Thank you and remain blessed. I love you all.